Welcome. In this video, we'll look at linear and rational equations. We'll start by looking at the calculator and how we can solve using the zero function. Step 1, write the equation in the form where the expression is set equal to 0. Then we'll graph y equals into the calculator and use the 0 or the root function to find the x-intercepts of the graph, also known as zeros. So in our first example, we'll go to y equals and type in the equation x cubed minus 5x minus 1. Notice that the equation was already set equal to 0 for us, so we're just going to take that expression and plug it into the calculator beside y1. And now we can graph it, and we're looking for these x-intercepts. To find them, we can use the calc option. Notice it's in blue above the trace key, so we need to hit second trace to get to the calculate option. And now we're looking for zeros, number 2. Now it's asking for a left bound. So we want to find the left bound of one of these zeros. So we're basically going to have to do this process 3 times. So I'm going to start on the left. I'm going to choose this x-intercept, and I want to be on the left side of it. Hit enter. Now it's asking for the right bound, so I'm going to scroll till I'm on the right side of that 0 and hit enter. Now it's asking for a guess. We'll hit enter one more time, and we see that we have our x-intercept. The x is roughly negative 2.13. And then we'll repeat this process for our other 2 intercepts. Second, calc 0. We'll scroll over to the second x-intercept, and again, we want to be on the left side of it. Hit enter. Then we want to be on the right side. Hit enter. Enter again, and we can see that this time the x-intercept is roughly negative 0.2. One more time to find our next intercept. Get our left bound, then the right bound, guess, and it looks like it's roughly 2.33. So the zero function is one way to find the solutions to an equation using our calculator. It's also a good way to check your answers later when we're doing it algebraically by hand. The next method using the calculator is going to be using the intersect function. Step 1, we'll let y1 equal one side of the equation and y2 be the other side of the equation. Then we'll use the intersect function to find where the graphs intersect or cross. The x-coordinate of the intersection point are the solutions to the equation. So in example 2, notice we have information on the left and the right side of the equal sign. If we wanted to, we could set one side equal to 0. We could subtract x and subtract 4 on both sides and have the right side be 0 and use the previous technique, or we could use this new intersect function method since we have expressions on both sides of the equal sign. So to do this, we'll go to y equals, clear anything that's already there, and in y1 I'm going to type in my left side of the equation, and then in y2 I'll type in the right side. Take a second to double check, make sure you don't have any typos, and we can graph it, and this time we're looking for these 2 intersection points. We're looking for the x values of those 2 intersections. So once again, we'll go to the calc option, second trace will take us there, and this time we're looking for where they intersect, number 5. So now it's asking for the first curve, and notice as you scroll that cursor is automatically on y1. So you just want to get close to that intersection point and hit enter. It's going to automatically jump to the second curve, hit enter, and enter one more time. And we can see that the intersection is at -2, 2. We're looking for the x value. The x value is our solution to the equation. Notice we have another intersection, so we'll repeat this process. Second calc number 5. And again, we want to scroll over and get close to that intersection. Hit enter. It's going to automatically jump to the second curve. Enter, enter, and we can see that 3, 7 is that intersection point. The x value 3 is the solution to the equation. So again, this is another way that you can check your answers later when you're doing these algebraically by hand. A linear equation is one that can be written in the form ax plus b equals 0, where a, b are real numbers. To solve a linear equation, we'll simplify each side as much as possible. Simplify essentially means to remove parentheses and combine like terms. Step 2 is get the variable terms on one side and the constants on the other side. Step 3, divide to completely isolate the variable. And step 4, you can check your answer. So in this example, we first want to simplify. Simplify again means to remove parentheses and combine like terms. So we'll go through and distribute the negative sign to remove the parentheses. Next, we combine like terms. Notice 8x minus 3x is a like term, combines to 5x. We'll just copy the rest. And at this point, you have options. Notice you have variables on both sides and constants on both sides. We want to move all the variable terms to one side and all of the constants to the other side. It doesn't matter which side you put the variable on. I prefer to put the variable on the left. That means I need to subtract 3x on both sides. And if we're moving the variable to the left side, we need to move the constant to the right side. So I'm going to add 2 to both sides. We get 2x equals -8. And finally, we will divide by 2. And x is equal to -4. Keep in mind that you can check your answer using one of the 2 previous techniques. Example number 4, we want to solve the equation that leads to a linear equation. So we'll start by simplifying. That means to distribute first. X plus 2x squared equals, here we need to FOIL, 2x squared minus 4x minus x plus 2. We'll simplify on the right side. And on the left side, I'm just going to reorder this so it looks a little better. 2x squared minus 5x plus 2. Combine those like terms. Now our goal is to put all the variables on one side of the equation. Again, I prefer them on the left. So I need to subtract 2x squared. If I do it on the right, I need to do it on the left as well. Also need to add this 5x over. Again, if I do it on the right, I need to do it on the left as well. And 2x squared minus 2x squared cancels. We're left with 6x equals 2x squared minus 2x squared. Again, goes to 0. That's going to go away. 5x and minus 5x cancel. We're left with 2. And so here we will divide by 6. And we get that x is equal to 2/6, or we'll reduce that to 1/3. Again, you can check this in your calculator. Up next, we have rational equations. A rational equation is an equation that contains a variable, usually in the denominator. So when you hear rational, think fraction. Right, we're going to be dealing with equations with fractions where x is in the denominator. To do this, we will first locate any domain restrictions. You want to figure out what x cannot be. Step 2 is multiply both sides by the least common denominator. Step 3 is solve the resulting equation, and then finally we can check our answer. So in this example, let's first identify what x cannot be. And to do this, you're always going to set the denominator equal to 0. And specifically denominators that contain the variable. And in this case, we just have x equals 0. X cannot be 0 because if x is 0, division by 0 here causes a problem. So our restricted value is that 0. X cannot be 0. Sometimes that matters, sometimes it doesn't. Next, we'll multiply by the LCD. And in this case, the least common denominator for x, 3, and 6 is 6x. So we're going to multiply every term in the original equation by 6x. 6x will multiply by the first term. Multiply the second term as well. And we can multiply the last term. Now we can go through and simplify or reduce these fractions. Remember, this is just a fraction. If it helps you, you can think of this as 6x over 1. If it helps you to put that 1 there to see that these are really just fractions. And when we multiply fractions, we can reduce before we multiply. So looking at the numerator and denominator of these two fractions, they have an x in common. That means that x is going to reduce out or cancel out and become just a 6 here. And in this second set of fractions, notice the 3 and the 6 have a 3 in common. So the 3 is going to go away to 1. And the 6x will become 2x. Again, the x does not cancel, but the 6 gets reduced to 2. And then on the far right, the 6 in the denominator cancels to 1. The 6x becomes just x. The 6 cancels with the denominator 6. So it gets a little messy, but it's going to clean up these fractions. Now we just go through and multiply. 6 times 3 is 18, minus 2x times 1 is 2x, equals 1 times x is x. And at this point, we have a linear equation. We've gotten rid of those nasty fractions. So from here, we'll repeat the steps from earlier. We need to move all the variable terms to one side. And I know earlier I said I like my variables on the left side, but in this case it's actually quicker since the constant is already on the left and there are no constants on the right. I'm going to move this 2x over. Right now it's minus 2x, so we need to add 2x to both sides. And we're left with 18 equals 3x. Divide by 3, and we get that x is equal to 6. Again, we can check our answer using the previous techniques in the calculator. More importantly, we need to make sure that the answer we found is not a restricted value. So we need to make a mental note to go back and check and see if 6 is restricted. It is not. 0 is the only number that's restricted. So we're good with our answer of 6. In this example, we'll first identify restricted values. So let's go through and find our restrictions. You might be able to just mentally do this in your head, but again, algebraically, what we do is we set each denominator equal to 0. Any denominator that contains a variable, set it equal to 0. So x plus 4, set it equal to 0, and we see that x cannot be negative 4. That's one restricted value. Our other denominator, x plus 6, set it equal to 0. Subtract 6 on both sides, and we see that x cannot be negative 6. So those are restrictions. Those cause 0 to occur in the denominator. And remember, division by 0 is undefined. So we don't want x to be those two values. Next, we'll locate our LCD. Our LCD is x plus 4 times x plus 6. And next, we multiply every term in the original equation by the LCD. So x plus 4 times x plus 6, we're going to multiply by the left side. Then we'll take our LCD, x plus 4 times x plus 6, and multiply by the right side. And from here, we can go through and see if any of those cancel. On the left side, notice that the numerator and denominator have x plus 4 in common. So that x plus 4 is going to reduce out or cancel when we multiply. On the right side, notice that the numerator and denominator have x plus 6 in common. So those will cancel. Now we go through and clean this up and multiply. So x plus 6 times negative 4, we just need to distribute this negative 4. Negative 4x minus 24 equals, here we're going to distribute the negative 3 to the x plus 4. We get negative 3x minus 12. And now we're left with a linear equation. From here, move all variables to the left side. So I'll add 3x to both sides. Move constants to the left side. So we'll add 24. And when we simplify this, we get negative x equals 12. Divide by negative 1. And x is equal to negative 12. Again, you want to make a mental note to go back and check, is that restricted? It is not. Only negative 4 and negative 6 were restricted, so negative 12 is good. Again, you can check your answer using the two techniques in the calculator. This equation has a denominator that is quadratic. To begin this one, we still want to find restricted values, but it might be easier to factor this denominator first before we look for restricted values in our LCD. So let's do that. Let's factor our denominator. Two numbers that multiply to negative 10 and add to positive 3 are 5 and negative 2. That's convenient. Those two factors already occur in the equation. It's not always the case, but here it's going to help us. So to find restricted values, we can see that x cannot be 2, x cannot be negative 5, and those are our restrictions. Again, if you want to algebraically do that, just set each denominator equal to 0 and solve. From here, our LCD. Our LCD is x plus 5 times x minus 2. Then we multiply every term by the LCD. So multiply the left side of the equation by our LCD. Then we'll multiply the beginning part of the right side. And then the last term. every term in the original needs to be multiplied by the LCD. And I'm going to write this in the factored form to make it a little bit easier to see what's going on. So on the left, it looks like x minus 2 cancels. In the middle, the numerator and denominator have x plus 5 in common. And then on the far right, it looks like both factors will cancel. So again, it gets a little messy, but once we multiply, this is going to be a much neater problem. So on the left, we have a 4 still, and then x plus 5. So we'll distribute that 4 through the parentheses, 4x plus 20. And that is equal to, over here we have a negative 3 left over, so distribute through the parentheses here, negative 3x plus 6. And then over here, everything canceled except for the 7, so we need to remember to bring down that 7. From here, combine like terms on the right side. So we get negative 3x plus 13. And here we want to put all our variables on the left. So we're going to add 3x to both sides. Move our variables, move our constants to the right side. Now we get 7x equals negative 7. Divide by 7, and x is negative 1. Again, make sure that's not restricted. It isn't. Negative 1 is not a restriction, so we have our answer. Again, keep in mind, you can check this in your calculator. Up next, we have extraneous solutions. A solution to a simplified version of an equation that does not satisfy the original equation is called extraneous. It's not always going to be obvious that you have an extraneous answer in the beginning. You have to go through those steps and then check your answer at the end. So we'll first look for restricted values. Notice that x cannot be negative 3. Then our LCD is x plus 3. We'll multiply every term in the original by x plus 3. So let's go through and now cancel. The x plus 3 in the first term cancels. The x plus 3 in the second term cancels. But the last one doesn't have a fraction, so that one's not going to cancel. Now we'll go through and clean this up. 2x equals negative 6. Distribute the negative 2. Then finally we'll combine like terms on the right side. Move all your variables to the left. So add 2x. We get 4x equals negative 12. Divide by 4. And we get that x is equal to negative 3. But be careful. Look at our restriction. Our restricted value is negative 3. If we tried to plug in negative 3 to this equation, we would get division by 0, which is a problem. So this is what we call an extraneous solution. The algebra says it works, but it actually doesn't because you get division by 0. So our answer here is no solution. There's no solution to this equation. The symbol we use for that, basically 0 with a line through it. In this example, we're going to be solving a formula for a specific variable. The steps to solve for a variable here are the same as you saw earlier. Don't let the letters throw you. The process is still the same as if we were solving the equations earlier. So start by distributing. To remove those parentheses, we want to distribute the p. Keep in mind our goal is to isolate this t, so we need to move p next. Right now it's a plus p or a positive p, so we will subtract it over. We have a minus p equals p r t. And here we have p times r times t. Still trying to isolate the t. This is all one big product. So to undo that product, we will divide by pr. And we get a minus p over pr is equal to t. And now we solve for t. In our final example, we want to solve for the letter r. We'll start by multiplying both sides by the least common denominator, 1 minus r. Simplifying on the left, we'll distribute and get s minus rs equals, on the right side, the 1 minus r cancels, so we're left with a. Again, our goal is to isolate the r. The first thing we need to do now is move the s, subtract it over, subtract it on both sides. Negative rs is equal to a minus s. And finally, to isolate the r, we can divide both sides by negative s. R is equal to a minus s over negative s. And we have isolated the r. Thanks for watching.